Hi guys, today is a product review day. We got a wonderful digital multimeter with oscilloscope and it's sponsored by Zotek. This is the ZOYI ZT-702S. Now let's learn about this wonderful product. In a soft case comes one adjuster for the oscilloscope probe. Its accessories for the tip and color bands. The thermocouple test leads, the multimeter with oscilloscope itself, the user manual is in English, and the USB kind C cable for charging the multimeter or connected to the computer. That means this multimeter has the batteries on board, and also you can save the pictures from the oscilloscope and export it to a document on the computer. To clarify some questions, I did some experiments about the test leads. So let's watch about it. The oscilloscope test lead is about 4 feet long. We are talking about 1.20 meters. Close to it is the multimeters test leads, and the thermocouple can stretch without any problem close to the 80 centimeters, a little bit more than 2 feet. Now, one by one, we are always expecting with the multimeter the test leads to be the standard Chinese ones, right? Yes, but this is not the case. The test leads with the ZOYI are special ones, very soft and with a beautiful sharp tip that is made for SMD components, for the smaller ones. Also, is rated for 1000 volts, 20 amperes category 3. Same situation with the thermocouple. We didn't get the standard thermocouple like most of the multimeters. We got a beautiful one with a spiral cord handler, and the tip is covered by stainless steel. That means this tip is made for liquids. Also eliminates a lot to transfer noise from the contact point to the multimeter. What is the downside is you have to wait some more seconds to reach the temperature transfer. Okay, you have to pay some price for something, right? But at least you are getting one professional, let's call it that way, thermocouple for the multimeter with the banana connectors that we already have in most of our standard products. About the oscilloscope probe, it comes with a switch 10x 1x for 300 volts or 150 in category 2. The tip is adjustable for the square waves and is for 60 megahertz. Now let's talk about safety. There is a yellow label. That means that you have to be careful when you deal with current. Remember guys, this is a measurement instrument and is a dangerous device if you don't know how to use it. The multimeter goes in parallel, has a very high impedance. The amp meter goes in serial. It's almost a short circuit. If you get the wrong connection and you put it in parallel, you are able to blow the multimeter and you can injure yourself, you will damage the instruments, and you can get the possibility of fire ignition. So be always honest with yourself, get the right training and education you need to deal with this kind of devices. Also, I know you're going to ask about it. I make a measurement from the resistance from the connector to the USB, and is open as it looks like on this picture from the BNC connector. Also, I did another from the negative of the multimeter to the USB, and I got an open connector. I don't know if there is a connection between the connectors shield, but remember, if you are going to work with main lines, do not connect the USB cable anyhow. Work with the battery, but do not work with the adapter. Now, after all the commercials, let's watch what is there. Okay, this is the screen. It doesn't need any presentation, right? We have function buttons, some extra buttons. It looks like that this is the power button, and we have a keypad. When it is charging, this button gets on red. Now, let's power it on. It's very fast to start. Mode will change from multimeter to oscilloscope and oscilloscope to multimeter. What I realize is I need to punch the buttons fast, because if I punch it slowly, it doesn't make any change. Unless the button is required for a holding for a moment. Now this is very easy. Function 1 is this icon, function 2 the next one, function 3 the next, and the other you can imagine too, right? Auto will change from auto range to manual range, so you can select the scale. Hold will keep on hold the measurement, or save will save the picture from the oscilloscope to the memory that you can export later with the computer to your files. Mode, we already know, made the switching. F1 is for selecting volts. If I want to switch between volts DC and AC, I have to do it like this. With F2, I will select ohms, continuity, diodes, capacitors, back to ohms. Let's remember, if I press auto, I will switch between auto range and manual range. If I hold it, comes back to auto. Hold to save that measurement, as we say. With amperes, I will get, by the first time, one alarm, about to be careful with the connections right down there, right? And the next one is milliamperes. By the way, it shows the value in microamperes. So somewhere there will allocate the dot when we do the measurement. Easy. Now the oscilloscope. Function 1, volt and time, and I can use the pad to make the changes. Move to move the signal when it is there. Trigger, I can adjust the upper or the downer size to move the trigger to get the signal. Also, in trigger, later in the menu, I can select if I want to trigger to catch the signal to be presented in the rising or the falling of the signal. And the next one, I can select AC or DC. with the menu, coupling AC or DC, the trigger manual, so I select where I want it, or single shot, or auto trigger. As I said, I can select between the rising or the falling edge of the signal. And the next one is the X1 or X10 for the oscilloscope. If I hold it, doesn't change anything, but if I press it fast, yes, it will. So some buttons are to press fast and others to press slow. As we say, with save, you can cache the image and export to the computer. Now we are experts on the device and now we can use it. Let's start in volts DC, and this is the voltage reference. 10 volts is perfect. Now quickly we will switch to ohms in auto range, and first we are going to get an image of the test lead. It takes some seconds to be about 0 point something, but in the first moment of the contact it's like 12, so that will be reflected on the first resistor. Right, 1 ohm. And the reason I say that is because the SMT test leads, they always have some extra resistance, different than the industrial electronics use test leads that has less resistance but more capacitance. Now the 10 ohms, the 100 ohms, the 1 kilo ohm. Here I'm not expecting to see the test leads resistance reflex anymore. 10K, $100K, 1 mega ohm, all the ones except the first one that was plus minus 5%, and the rest are 1%, but this is plus minus 5%, 10 mega ohms. Right, now let's go to diodes. Fast diode, silicon diode, red LED, yellow, green, blue, and the white one. Hard to see always because I have the light just in top of it. Let me decide to turn off the light. I will try to put the finger up. I need to turn off the light. There you go, everybody's happy. The white is lighting. Capacitors. This is supposedly 101 picofarads. One nano, 10 nano, and it's 10.7. It's very alike, and 100 nano says 104, and it's 104. The device is on the specifications. On the temperature test, the multimeter says is 26 degrees. Another device that I have next to it, it says 27. It's 1 degree difference. Probably the multimeter has more accuracy than this device. Both are with external measurement. For 1 volt RMS in 1 kilohertz, we can test the true RMS, and it says 0.998 volts. The multimeter is on the specifications. Now I will make a pause here, record the rest of the video. Because it has been on for several hours, I'm already running out of battery. Alright guys, battery is already charged, so let's continue with the video. I connected the function generator to the oscilloscope and I got something. What did I get? I don't know. Am I on the right setting? Probably not. But this device has auto for the multimeter, auto range. But if I press auto, it will set up the oscilloscope too. Easy, right? We're going to do the probe compensation, so follow the next steps. Switch the probe to 10x. Connect the probe as it looks like on the picture. The probe up, the ground down. Now you will get a square pulse. And with the tool provided by ZOYI, we are going to adjust this signal until we get the right angles. This is lacking of compensation and this is overcompensation. Now it is okay. Beauty. Now let's remember with volt time we can switch in F1. We can adjust the voltage scale or the frequency scale up and down with the keypad. Supposedly this device is able to work on the 10 MHz. Let's see what I get in 1 MHz. I will switch now from RMS to voltage peak to peak in the function generator, so we will know what we are talking about. In the function generator, there is 1 MHz, 1 volt peak to peak, and in the device there is 1000 kHz, what is 1 MHz, and 0.96, what is very close to the volt peak to peak. So that's great for this device so far. What is the maximum approach I can take from this screen? Let's find it out. I am in 5 MHz and that's the end of the horizontal scale. So to get a full wave is 1 MHz. I can see nicely until 5. but probably 10 MHz will be on the end of the device capability. Yes, it's already noisy. Back to the 5 MHz. It looks nice if it is a sine wave, but if it is a square wave, this is what we get. So let's come back to the 1 MHz again. In the rising and the falling edge, it will come the moment that the timing is so close that it will look like a triangle wave. So to 1 MHz, one square wave is visible. Probably in 5, it looks like a sine or triangle wave, because that time is already so visible that will come the moment that will close like that. Probably the maximum approach for the square wave is in 1 MHz or maybe 2, but after that it has the tendency to look like a square or triangle wave. 2 MHz. 3 MHz. 4 MHz. 5 MHz. 10 MHz, forget it. So 5 MHz doesn't help too much in the square wave. Also, we call the bandwidth is correct until we get minus 3 decibels. In this case, we are upper of that level. It's more than 1 volt. I will say for radio frequency tests, this is not the kind of device we are looking for. However, to have a multimeter able to show display in 2 MHz with high fidelity, what we get is a great device. As oscilloscope, let's say if I want to check in a switching power supply and debug stuff with a battery operated oscilloscope in the hot area or something like that, the switching pulse probably is in the order of the 15 kilohertz, 250 K or something like that. So this oscilloscope is way up on that. So it's good for testing in hot areas, in switching power supplies, and the bandwidth is enough for it. So we got a wonderful multimeter, and let's say 2 square wave, 5 MHz sine wave measurement instrument oscilloscope to see what is going on, get an idea about it, to the 10 MHz oscilloscope. Excellent instrument, I like it a lot, but also the company, with all the features the device has, a good quality oscilloscope test probe, the SMD tip on the test leads was a plus, wonderful, and the luxury thermocouple for liquids was great. I think in digital oscilloscopes on multimeter is one of the best devices I have seen so far. Anyhow, remember guys what I told you always about multimeters. There is not the best multimeter. The best multimeter is the one that fulfills all your needs in the measurement. However, with the capability and the features of this device, I consider it's an excellent instrument. Thanks ZOYI for the instrument. I will use it not here in the front panel of the videos, but on the next table where the repairings are, in substitution of this other guy who makes a wonderful job there, because offers a lot in just a small device and is good enough for repairings. So congratulations to the company, got a very good product, satisfies many needs, and I think the product deserves a like. See you next time in another video with product review. Thanks ZOYI again for the device. Don't forget to like and to share.